Okay, so I'm back again. Now we're going to continue with our areas of integration where we kind of began yesterday, and we established that when you get the area, what are you really getting? When you're getting the integral, what are you getting? You are getting the area underneath the curve, right, and the y-axis. So you're getting this area here underneath the curve and the y-axis. The limits here are b and a. So your upper limit will be b, your lower limit will be a. So integration gives you the area of that red part shaded there, right? This one, right? If you looked first, right, to get the area between the curve and the x-axis, there's two parts here. There's a part here which is between the curve and the x-axis, between these two limits, isn't it? Now that's obviously going to be a positive value, right? But down here, the area between the curve and up to the x-axis, this area would be negative, right? Because it's underneath the x-axis. Now we know that you couldn't get a negative area, right? So you'd have to take the absolute value of it, which would be the positive. What limits would you use here? You'd use this limit and this limit, right? Whatever values they would be. How would you get those values? You'd get the values because they're the roots, aren't they? They're where the graph cuts the x-axis. It's a cubic graph, so it has 3 roots. 1, 2, 3. You'd use the first 2 as your limits for here. You'd use these 2 as your limits for here. And then you'd add your 2 answers together when you get your 2 values. Same here. This one, this time, finds the area between the curve and the y-axis. So your question will be phrased differently. It's just not the x-axis. So this time you use the limits b and a. Look here, right? Again, you're looking for the area between the curve and the y-axis. So when you get the area between the curve and the y-axis for this part here, it's between here and here when you integrate, using the limits there and there, whatever those values would be. This will be positive because it's in the positive y-axis. This will be the negative value because it's in the negative roots or values, 0 minuses here. So we know that it's the absolute value we take, so we'd add your 2 answers together and take the positive sense of them, right? So that's telling you the area between the curve and the x-axis, which is the same as integration, basically. Now, when we look here at example number 1, in example number 1, we are told that we have a curve, y is equal to 3x minus x squared. Now it represents a quadratic curve, right? Y is equal to x represents a line. So here, 3x minus x squared is a curve. Now what type of a curve is it? It's a U-shaped, right, curve, or sorry, in-shaped curve because it is a negative x squared. So find where this negative in-shaped quadratic curve crosses the x-axis. So for x-axis, we say y equals 0. So y is equal to 0. 0 is equal to 3x minus x squared. Now you could solve it doing factors. Take out an x, right? So x is 0. 3 minus x is 0. So 3 is equal to x. 3 equals x, right? If you didn't factorize, you just do a quadratic expression, right? Minus b. So these are your roots where the graph cuts the x-axis. So here, 0 was 1, 0 and 3, where the graph cuts the x-axis. The next thing says, now find the values of x where this curve and this line intersect. So let's say this is my curve, which we have, cuts the x-axis at 0 and at 3, right? The line is y is equal to x, that goes through the origin, right? So y equals x is your line, y equals 3x minus x squared is your curve. How do I find where the two of them intersect? I can see in a way the two of them intersect there at those 2 points. How do I find those 2 points? Obviously put the two equations equal to each other because they're both y's. Y and y are equal to each other. So I'll say x equals 3x minus x squared. So y and y are equal, so that and that are equal. So 0 is equal to 3x minus x squared minus x. So 0 is equal to 2x minus x squared. And I solve. 0 is x, 2 minus x. So x is 0, 2 minus x is 0. So 2 is equal to x. So x is 2 and x is 0. So 0 is where one of them meet. So that has to be 2. Not really look like it from the graph, but if it was drawn accurately. So they would be your limits as such for where the graph and the curve intersect. Now, draw a rough sketch, so I have that done now, right? And draw a rough sketch of the curve and the line and find the area bounded by the curve, which is this guy here, right? The line, which is this guy here, and the x-axis, which is this guy here. So you're looking for the area that incorporates all three of them. So if you looked at your area, what you're really looking for is the area bounded by the curve, the line, and the x-axis. So you're going to be looking for the area of, let's say, this part here, even if you want it. Right? This part there, the curve, the line, and the x-axis. So you'll use your two values. Now, let's have a look at it. The curve, the line, and the x-axis. So we'll see what we'd have. If you looked at it here, you're getting the area between the line and the x-axis between 2 and 0. Isn't that right? The line. So there. So you get the area under the line between 2 and 0. What's the equation of the line? Y equals x. So you get that area. Then you'd have to turn around after that and get the area in here, because that's between the curve, the line, and the x-axis. That's taking the curve into account. So I'd have to get the area then between the limits 3 and 2 for the curve. 3x, minus x squared. Okay, so I'd have my red and my green, and I'd add the two answers together, and that would give me the whole area between the curve, the line, and the x-axis. So you can see the curve, the line, and the x-axis. And that takes all the area into account then. So you look at, first of all, getting the red part, which is the area under the line, between the line and the x-axis, and the limits are 2 and 0. Then the curve and the x-axis will be using 3 and 2. So we'll get the integral of each one. X squared over 2, evaluate it at 2 and 0, plus 3x squared over 2 minus x cubed over 3, and again evaluating it at 3 and 2. So where did I get my first ones? What will I have? I'll have 2 squared over 2 minus 0 squared over 2. Take or add on, right? 3 by 3 squared over 2 minus 3 cubed over 3, right? Take away 3 by 2 squared over 2 minus 2 cubed over 3. So that's my second part, isn't it? So this is 4 over 2, which is 2. That'll be 0 plus. Work out each one here. So 3 squared is 9 3s are 27 divided by 2. So 27 over 2. Minus 3 cubed is 27 over 3, which is 9. Minus 4 3s are 12 minus 6. So this is minus 8 over 3. Now you can put them in your calculator. I'm just doing them out. So here what will I have? 27 over 2. So 27 ABC2 minus 9 is 4.5. Take away minus 6 minus 8 ABC3 is minus 3 1/3. Oh, that's plus, isn't it? Yeah, so it's 3 1/3. 6 minus 8 ABC3. Yeah. So what is 4.5 take away 3 1/3 gives me 1 1/6. So my answer will be 2 plus 1 1/6, which is 3 1/6. And it's 3 1/6 square units, because it's area. Okay, or units squared, whatever way you want to write it. All right, so that's the first one, example number 1. Right, so they take you through it step by step there. Right, I go on now to example number 2. And example number 2 is here, right? Finding the area here, bounded by the curve. This is my U-shaped curve, x squared minus 2x minus 8. Right? This time they didn't ask me to find where it cuts the x-axis, because they gave it to me. This curve cuts the x-axis at minus 2 and again at 4. So they're your two roots, aren't they? So what you're asked for is to find the area bounded by the curve y is equal to x squared and the lines x equals 1 and x equals 5. So they've given you two lines. Find the area bounded by the curve, which is there, and these two lines, right? So the curve and these two lines. So this is the area. So you're getting the first part, which is area number 1. So that's the area between the curve, there, see it? The curve, and the limits 4 and 1. So the curve using the limits 4 and 1. What are they? You have x squared minus 2x minus 8, right? Then after that, you get the area of A2 and you add it on. So the area of A2 is the area between the curve and the x-axis for 5 and 4. 5 and 4. Right? So I have x squared minus 2x minus 8 and I evaluate each one separately. So x cubed over 3 minus 2x squared over 2 minus 8x using my limits 4 and 1. Same here, x cubed over 3 minus 2x squared over 2 minus 8x, this time using 5 and 4. Okay, they'll obviously divide into each other to give me 1. So I'll have 4 cubed over 3, 4 squared minus 8 by 4, take away 1 cubed over 3 minus 1 squared minus 8 by 1. That's the first one. Right, adding on this time 5 cubed over 3, 5 squared minus 8 by 5, and then I have 4 cubed over 3, subtract, put it in a bracket when you're subtracting because you'd very easily make a mistake, minus 8 by 4. Alright, so evaluating each one of them, I think I did that out already, maybe I didn't, no I'd say I didn't, hang on, we'll see. I have 4 cubed divided by 3 minus 16 minus 32, that's 2 1/3 and I read that part, I'm just doing it quickly. Then 1 ABC 3 minus 1 minus 8 is minus 8 and 2/3. The two minuses will make plus. So minus 8 and 2/3 and 1/3 is 11. Is that right? I'll just check, make sure they're correct. That looks like it should be a bit bigger. 8 cubed divided by 3 minus 16 minus 32 was 26 and 2/3. Right on there, 26 and 2/3. Right, and then I am adding on 8 and 2/3 and I get minus 18. Is that right? That can't be right. 26 and 2/3 plus 8. Am I right? I'll just check them all again, make sure I'm right. That looks okay. Isn't it? Right, then I'll move on to the next one. And I'll get my value here. I think that's 18. Right, then here I have 5 cubed divided by 3 minus 25 minus 40. So that's minus 23 1/3. And then I'm subtracting 4 cubed divided by 3 minus 16 minus 32. And I think I got minus 26 2/3 already for that. The two of them will make plus, right? So I have 26 2/3 minus 23 1/3, and I got 3 1/3. So it's 18 plus 3 1/3. Now let's remember again, I said if one of them come out negative, so if this one was a negative answer, if this one was a negative answer, we take the positive sense because it's the area. So your answer is 21 1/3, isn't it? Right, square units. Okay, so that's the area of these two parts. Now, again, like I said, if it's a diagram like this, where it's bounding the y-axis, let's say this is my expression, I'll be able to find where that cuts the y-axis by saying x equals 0. So 0 is 16 minus y squared, right? Y squared is equal to 16 when you bring that over. Y is the square root of 16. Y is plus or minus 4. So that's 4 and minus 4 are your two limits. And again, you'll integrate this time 16 minus y squared, 4 and minus 4. You're just using y's instead of x's. And you sub in each one. Is that okay? So it's just might be written a little bit differently. Right, now we'll go on and I'll leave the next example until tomorrow. So what I'll do now is I'll set some questions for you to do yourselves tonight. I'll write them up there on Google Classroom and you can submit them by the specified time and make sure and correct them at the back of the book first and then submit them. Alright, so that's your areas. Go back over this video now if you need to.